Hello everyone, we are the steering division of the NASA Mars Rover group. We want to start off this progress presentation with some prototyping stages to show you 3 different prototypes we have going at the moment.
One of the prototypes that our group has chosen to design is a spectrographic analysis tool. The objective of the tool is to have a physical device that can attach to a phone and change the color filter. We must include a red, yellow, and blue filter, as well as an unmodified one. Our device clips onto a standard iPhone, and the torsion spring in the middle of the device will provide enough friction to fasten the tool to the phone. There is a wheel with 4 multicolor quadrants that can be positioned in front of the camera lens, providing the user with the ability to change the color filter rapidly. For our final design, we will have a hemispherically shaped knob that sticks out of the clip, and it will mate with 4 holes on the circumference of the wheel, preventing the wheel from undesirably rotating. We will replace the current spring with a smaller, weaker one, since our current spring puts too much stress onto the prototype.
For our second task, we are assigned to design and create a tool to collect 3 different liquid samples. Part of NASA's requirements is to include middle schoolers and have them help us. So we have been working with the Malcolm Bridge Middle Schoolers Inventor Challenge Club to complete our task of designing and creating a 3D printed tool for Herc's liquid sample retrieval task. We have been taking them through a simplified engineering design process so that they are able to help us create both the container for the liquid sample and the tool that will hold it. Just recently, we were able to 3D print the container that the middle schoolers successfully designed for us.
The retrieval tool has a pour spout to ensure laminar flow when pouring the liquid out. Also, while you're pouring the liquid out, there's a raised lip on the inside to ensure that none gets past the pour spout. On the outside, there's 2 lips that give it a nice secure grip when the arm grabs the tool.
Our first step for prototyping was updating our design in CAD to add a method of attaching it to the rover. In order to do so, we added an outer metal frame for the gears and rods to sit on, which will also connect to the rover frame. Here we have a little video showing how the different parts of the steering system will interact with each other in CAD. After making sure our design met the standards, we started 3D printing it to have a working model. Here you can see the spur and bevel gears as well as the toothed rod and handles being printed. This process took about 12 hours to complete. Finally, we have our finished and assembled 3D print. As you can see, it works just how we intended, so it should be ready for us to start building.
To progress from the prototyping stages, we needed to implement all of our parts and see that we had everything ready to fit. Shown here is our 6-foot track. We plan to split this up into 3 feet and 2 1.5-foot lengths. This is the threading that's on that track that is going to match up with our gear combo. Like in the prototype, we have one much larger bevel gear and a smaller one made to match, the bevel one matching the track and the smaller to the gear. This side view is to show you the different angles of our larger and our smaller bevel gear and how they'll come in contact with each other. The connection will look like so and rotate as follows. A large portion of this project is making sure our steering assembly is attachable to both the chassis, but not in the way of the suspension team. We have lots of aluminum bar, rebar, hooks, and fasteners to make sure this is possible. We believed it best to have extra of such materials, seeing that whatever is not in our 3D model, we can use for extra support and structure. These rod clips will help in our rover having a full 180-degree rotational turn, as well as keeping our track in place. Because steering is also in charge of the braking assembly, we chose to use caliper brakes as seen on a bike. We had to order extra cord, shown in the top left corner of this video, to ensure we can elongate the cord all the way down to both ends of our wheels.
The next steps that our group plans to take in order to move forward with our design project is to finish up the welding modules so that we can use the fabrication lab. Once this is completed, we'll be able to cut our parts and size them to fit, weld our gear and track combos, address integration changes for our steering assembly, as well as provide steering assembly structure and supports around the chassis and suspension. Once all of these tasks have been completed, our group will be ready to test our model.